Hello and welcome to another episode of the Cliff Notes podcast, where we ask a leader and find a way. Today Colin's joined us from Tri-Tech 3D and Cadspec to talk about additive manufacturing. So let's just jump straight into it.
Tooling using auto material that can then be used for composites. So it then brings into the realms of carbon fibre and Formula One teams, and it becomes quite an exciting sort of adaptation that you're not just making finished parts, you're making tooling in the material that can be making the finished parts in the material the customer wants to use.
Okay, so it's not just sort of exotic metals and materials that it can replace. It can replace some more common parts. Yeah.
Yes, I think that's the key thing. Yeah, it's seeing how things are traditionally made, and then look at maybe using additive as an alternative approach to things. And it could be just as simple as the custom low volume parts that people tend to ignore or are too expensive, that can be sort of additive manufactured. It doesn't mean that you can make everything in plastic that would normally be made in metals. There are certain things that can only be made in metals. On the additive use of metals, again, is growing in manufacturing. Some of the key people, certainly medical implants, for example, titanium implants, acetabular cups, which are sort of hip implants that have a structure on the outside that sort of mimics bone growth that allow you to recover better as a patient. So,
oh, that sounds great. So are you seeing sort of a different uptake in different industries that you work with then?
Yeah, it's I suppose the traditional additive technologies, the aerospace, for example, where you have companies like GE that have bought two of the largest additive manufacturing suppliers with Concept Laser and Arcam. GE Additive now is a massive global that it's the battle, not the battle, it's just sort of the education and approach of using additive in conventional processes. It's understanding and learning their language, which is the initial thing that you have to go in there and understand where you start to see the benefits. The latest machine that's just come out from Stratis, launched a couple of weeks ago, called the J55, is going to be aimed at everybody who wants to design something in colour. It's going to be the most amazing sort of office-based process of where you can now print something in a Pantone colour, where you can actually have all of these various colours, which conventionally you'd 3D print it in a white or a grey or a blue, and then you'd manually go and paint it and spray it and do whatever you know. And now with this J55, you can virtually now just create any sort of coloured part that you want. And as a design house, it's going to be an amazing development. So it's opening up new markets. Every time there's a new material, there's a new machine, there's a new thing, it starts to open up more boxes that hopefully sort of bring in different applications.
Great, and just to go over that then a bit more, I mean, what happens with that as a process? You're adding the material and you're adding particular Pantone colours that you'd need to stock, or how does it work to produce the colours?
Well, what you have, there's various software that will allow you to create a CAD model on the screen in the colours that you want, and then the information on that colour is then sent to the printer. So we work with a software on all of our Stratis machines called GrabCAD that can interpret that particular model that's been imported. It's imported in a way that allows it to capture all of the colour data that's been created through the original CAD software that you use. So then you can look at the textures, you can look at the colours, and with this J55 being an inkjet printing technology, you know, if you look at just how you your own printer works at home and you just got a picture of something and you say print, it just prints. And you think, how does it mix all of these colours together? And that's really, imagine that in a 3D format, and that's what we can now capture with this J55. And have it being able to print out with colour that you want it. So it has to be a Pantone ABCD.
Be next to giant machines printing off big rolls of colour work. So we're tinkering around and seeing what you can learn. But to be able to do that also in 3D is a bit of a game changer of moving things forward again.
Yeah, I think that it's trying to differentiate between two types of plastic 3D printing and the FDM extrusion type printing. I'm not mentioning names of customers as such, but people that make sort of hand tools that want to have a grip that's got a certain type of texture and it's got a certain colour, it has to match their brand. But you want to have that visual representation in someone's hand straight away before they then go and make proper tooling and things like that. So it's the thing with the FDM process, it can now manufacture and make end-user parts. PolyJet technology is still generally, to a certain extent, still within the design and prototyping phase, but it's really ramped up the or shortened the lead time now of being able to have real life physical parts in your hand. And this J55 can actually print in what's called a draft grey, so it can actually print a very, very fit form and function prototype, as well as next to it on the same platform, printing the fully coloured model as well, which would use more of the expensive materials.
That sounds really good. A bit more efficient if you just need to get some prototypes out first to check that you've got the right form.
Yes,
that's
the initial thing.
Yeah.
And in some cases, is that close enough? Yeah, that's okay. Now we'll sort of go to a full-blown model that you know is going to cost a lot more to print. A material that people want to work with. For example, if it has to be a grade of aluminium or a grade of stainless steel or titanium, I think the range of materials, although it's increasing, it's nowhere near match what you can conventionally sort of buy off the shelf or go down to your local steel stockists. So I think the first, it is a limitation, but it's the first thing that is which material do you want to build your metal parts from. Then once you've built it, normally you've then got to post-process it. So you may have to CNC machine it. So you may have to polish it, CNC machine it, if you want a highly accurate part. So I think the use of metal additive has still got this, what's the benefit? So it's, you might want to have it with a type of lattice structure that you can't see at the machine, or internal cooling channels that are curved rather than flat. So it's sometimes the real benefits of additive are not things that you can see because they're on the inside of things.
Right.
The medical implant side, like I mentioned earlier, is really to do with the you can put like a sponge titanium structure printed on the outside of something while printing it solid on the inside. So you can get this feature on the outside of it, which means that bone can grow onto the outside, meaning patients recover quicker. But in additive and medical implants, it's more to do with this control that you have on the outside surface, rather than trying to make something that's a customised jawbone for a particular patient that's had an accident, for example, which still goes ahead.
Mm-hmm.
And you're going to do that. And it's quite interesting that probably about 12 months ago, a a friend of mine, he had his whole rib cage, not his whole rib, but a good proportion of his rib cage had been diseased, and it meant that they normally would cut that out, fill it with concrete, and that's it. But now he's had a titanium sternum plate made, and you know, if you went online, he just said the 3D printed man with a titanium rib cage, the guy called Eddie Evans, and I used to play football with him. So I say how my technology impacts on people that I know. So it's very, very customised, but it can also mean that for more production-based processes in medical, then the implant technology is something that's good.
Sponsorship of this podcast has been brought to you by Holding Bay, the digital web agency. Holding Bay specialises in working with B2B companies like manufacturers to build better solutions and drive better sales funnels. So if you would like to build a web application or improve your branding and sales funnel, get in contact today. holdingbay.co.uk or call us on 01273 044 019.
Aerospace is all about lightweighting. If you can save half a kilo here, half a kilo there on something, it can make massive differences. The other areas where people conventionally have parts that are made up of several parts together, so you either need to weld them up or you need to bolt bits together, you can now print as one. So it's been able to combine and condense traditional things that took 20 parts, you can now make in one. Heat exchangers, things like that, where you sort of want to direct, whether it be water, whether it be oil, or whether it be air, down a channel that you want it to go to give you improved conductivity or heat dissipation. So it's lots of areas where it's used, but I suppose the rule generally is if you can CNC machine it, and it's cheaper and it's quicker and it's better, use CNC machine it. You don't just use the technology because it's sort of great to use. You use it where it can still save you money and benefit.
Right. Right. Yeah. I mean, that's where I was trying to get to understand, and you inspired me a few different questions with that little bit. So take it a bit slower. So I mean, is there a rule of thumb or a guidance, or it is still down to experience and talking to a sort of professional partner as to know when there is a reason to look at 3D printing? Is it just because a part is becoming complicated to machine, or are there other ways that you would choose to at least consider a different technology?
I think that the pace of CNC is moving in as quick as additive. I went to an open house at NASDAQ in Worcester last year in November. I was blown away with some of the things they can just CNC machine nowadays. Some of the cutters and some of the way that these 5, 6, 7 axis machines can throw parts around. I think where benefit additive comes in certain applications is how these parts are held. That you have a certain type of fixture that allows you to have like an organic sort of look to it that allows it to throw it around so it can virtually machine upside down and back to front. So what I see is additive is not to replace subtractive, but to really try and complement the whole manufacturing process. It is materials that are sort of key. Additive materials that are generally used, stainless steels and tool steels and things, are probably not as beneficial to the aerospace and medical world, with titanium and aluminium being high on their list. And it's these are highly reactive materials and generally need a more expensive type of additive process for it to be successful.
Right.
That you're not going to get every. You do see that, we can print in 20 different materials, but then when you dig into the actual details of it, most metal additive machines, you tend to dedicate one machine to one material. to swap out a load of aluminium and put in a load of stainless steel and then take that out and put in titanium, this, that and the other, it would be a big no-no for aerospace and medical companies. They would just dedicate a material and a machine to that.
Indeed.
Cross-contamination is a big factor, and trying to get that to work generally across the board with machines is quite difficult. Certainly when you're working with very fine powders, and there's the safety things that you need to be aware of, but cross-contamination and things like that are also big considerations that mean that if it's to take off, it then has to look at adding more machines to the process to be able to meet capacity, which becomes expensive.
Right. And so if you're a plant or a workshop and you're looking at additive, is it the sort of thing that it's worth you can cross-train that people, if you're producing your own CAD, you can learn and adapt, or is it something that it's better to work with another partner first, just to get the understanding of where the benefits are and some changes that you might need to make to your process?
Yeah, but that's a good question. I think if I look at a number of tool making companies I've tried to introduce additive into, it's been quite difficult with conventional processes. They say, well, it's still easier to CNC machine, and if that's the answer, then that's the way you do it. It's when you start to look at areas where you think, well, I've got a very expensive 5-axis CNC machine over there, and that shouldn't be making jigs and fixtures and tooling all day because that's not making me money. It's the part. If I can 3D print these in some way, then that's freeing up some of the capacity on the more expensive machines. So I think that it's like I said, it's trying to blend that in. But if you think, well, I've heard about this 3D printing, I want to get myself a metal one so I can make these bits and pieces. Although that's where the conversation starts generally, they don't always need it because what they're trying to use it for is easy to CNC machine.
Mm-hmm. So is the return on investment? I mean, I'm going to guess the answer, but a machine is not really for sort of incidental and seldom use. You do need to be doing some sort of volume through it to make it pay for itself.
Yeah, if you yes and no, and I think yes is probably the overall answer to that. You don't tend to be making one-off parts with the technology. You tend to be batch building parts. If all of these parts have a slightly different feature, it had a different serial number on it, for example, so you can print lettering and engraving on it. You can it can be slightly customized to fit a particular application, should we say, so that you can print, which is a good thing, 20 parts all at the same time to get the most effective benefits on the process, but each one can be individual and customized. If you put one part on, you're printing it, and then you're taking it off, putting another one and printing it, you know that's not a cost-effective solution. Additive, the great thing about that, it is a sort of lights-out process. Most CNC machines generally would need an operator there all the time. So it is quite different. I think the one thing it has to be sort of emphasised is that additive manufacturing in metals is really comparing it to like a digital casting, where if you know conventionally that you bought a casting that had to have features machined, holes threaded, things that to give you accurate, you would still be doing that with additive. It's a very complex digital casting, but you would still generally have to look at maybe finishing it. But the nice thing is that if it's a sort of quite a curvy sort of shape, a manifold, for example, that you can 3D print a fixture for it to sit in so it can hold it and locate it at the angle that you need to finish machine it. So it does offer some great additional benefits to subtractive. sort of the modern, not the modern, the sort of new push of using the technology is not to get a design of something that you've already made and see if you can 3D print it, but look at that design and see what you may want to get out of that to benefit that design better. And generative design now is the sort of some of the key software things that have been brought into play, where you can just take a simple location of a lug and a bracket, and from that lug and bracket you can apply forces into that design, and then it will come back, go up to the cloud and come back with various alternatives based on whether you want to CNC machine it with the existing stuff or you want to use it for additive. So we can go up there and come back with 50 different variations of your original Boolean design features, and then you can say, yeah, I'll have part number 3 and part number 7. They are offering me the same benefits, and it's 20% lighter, and I can use that on my 3-axis milling machine, and then you can go away and machine it. So it's being able to have these software tools now available that means that it can design things that you'd never even think of. I think that's some of the key benefits going forward.
So raises the ceiling or moves the goalpost a little bit on something that you might have thought you got to the limits of. There might be a new avenue, not extending what you were doing before, but taking it a different direction to achieve a better goal.
Yeah, I've seen areas, a lot of drone technology that I've seen now where they've been making aluminium carcasses can now be made in carbon fibre, nylon carbon fibre. If you imagine like a spider type configuration that's been CNC machined, you think, how the hell am I going to redesign this? You can just look at maybe where the 6 motors are placed in that design, and you can then come back with a completely organic design made for additive, or it can be conventionally machined, but be 20% lighter. And if your overall objective is to make this drone 20% lighter, it might mean that you only need 4 propellers to lift the load, or if you've got 6, you can then lift a higher payload. It's the whole benefit of reducing the weight. Can sort of make the whole design process a lot better. And I'm seeing things like that in sort of UAVs and drone technology, where you can't then look at just look at redesigning it. You can then use sort of the generative design sort of options, and working with Autodesk, there's so many things online that you can look at from this point of view to get an idea of what it's capable of doing.
Oh, that's great. Just to wrap up, because I appreciate your time today. With shows like Mach and stuff closed this year for or at least delayed because of the COVID-19. How can people sort of get hands on or get experience of this stuff? Have you got courses or advice on working with people at the moment?
I think with normally you get the message across through Mac, through sort of TCT, which is the 3D printing one, through Formnext and things like this. Nearly all of these manufacturers, whether it's Stratasys, whether it's Desktop Metal, Autodesk, you can go online and there are webinar after webinar of any topic that you want, running all through June now. Desktop Metal is one starting at 3 o'clock, things like that. So in the last 10 weeks, it has been quite extensive and really informative on a lot of these companies that are now doing everything online with tutorials, with training, with education, far better than what you do at Mac when you're trying to talk to somebody for an hour and you've got that person's attention for 10 minutes because there's 20 people waiting to talk to them, and you can play it back. You've got hands on so much information at the moment. It's been quite incredible in the last sort of couple of months.
That's great. And have you've been getting on a few calls and webinars with people too then?
Well, yeah, because there's no point recommending stuff unless you've probably seen it yourself, and then you can target customer A, B, and C. This would benefit those guys. MakerBot only last week has launched a new carbon fibre addition to their method printers, and I think, wow, that's going to sort of shake things up a little bit in the carbon fibre market. And there was a webinar, so I sent that out to a couple of people this morning. So what we try and do as a reselling partner is to look at an area where something's newly released and try and target a specific range of customers. There's just so much stuff on the moment. But you just need to go to the Autodesk website, Desktop.net's website, Stratasys. There's so much information. Use LinkedIn a lot, I suppose, to educate people. If something comes through, and then you can share that with your customers. I find that a useful tool.
Got myself in for
details. But generally, if you look at the manufacturers that we deal with, then they will all have access to that. It depends how personalised you want it to be. If, for example, you're a customer that's got a particular model that he wants to either have it designed or he wants to have it 3D printed, and he's looking at what's the best technology to use, so it's probably best to come direct to us so we can look at that. We've got all of their guys have got various softwares on their laptops. You can quickly put parts through to say, yeah, that is a viable part, and you can send the information back quite quickly to customers. The misconception to a certain extent is that certainly with the current interest in additive is that anything and everything can be 3D printed on a print that you can get for 50 quid off eBay. And because it's a 3D printer, it's like any sort of technology or anything like that. You've got entry systems that have a certain level of capability, but what you may want out of the technology might cost you a few £1,000 rather than a few hundred.
No, I think that makes sense. So definitely.
We educate a lot of people, and that's their job as much to try and what's the word I'm looking for? To try and advise people which is the best route, and sometimes it's not down a route that costs 50 quid off eBay, unfortunately. Generally, they're very, very robust. So you could be having a printer that's 200 kilos, for example, in weight. It's fully sealed heated chambers, things like this. So having these fundamentals in place have come through the experience of Stratasys over the years to say that unless you've got a robust foundation and a chamber, you're not going to always get the best results out of the process. And that's going through the experience of inventing the technology, and over the years realising that you've got to have this as your initial starting point. But it doesn't mean that you can't get good results off some of the cheaper systems, but it just means that you can't do everything on every system. Otherwise, it is on an application basis. An FDM machine that's going to be this, that's going to be a MakerBot process, that's going to be an object technology. So when parts come in, we can identify quite quickly what type of process. So there's no one system that does all, and then fits within the price bracket that everybody wants to pay.
The right tipping point. Well, no, it's been great for you to be able to run through that with me today and give me a lot more insight. Could talk for hours. I can feel so much history in there and knowledge that you've got to dig in and learn more about the sort of case studies and understanding of it. Have to catch up again.
Just point people in our direction if they want.
Yeah.
Any further help, I think, is the key. It's in the last 10 weeks, I've taken so many calls from people wanting to make visors and things like that. Possible. Care centres and things like that, but now that volumes can maybe produce, and hopefully that's been a good result, good win-win for all manufacturing, I think.
Yeah, it's been almost exciting as well that maybe the technology also gets a bit of excitement in some of the younger generations also to manufacturing. A few students have been working with local companies doing their sort of 3D printing and working with the sort of PPE and getting investment because they had an idea and they started working on it, but then they've been able to have the opportunity to then partner and work with more sophisticated companies who've had the experience of how do you scale that, how do you make that work. So it's sort of exciting case studies and stories coming out too.
I think everything starts with an idea in your head and they're offering that free now to anybody to the end of June, and that is to me one of the most exciting CAD packages I've ever seen. It gets you to such a high level of things you can physically make, and engaging with students on that, and there's so much online, and it's free. It's only free for education. There's lots of free software out there, but Fusion 360 for me is the best.
In a bit later.
Interest, take care.
That's great. Well, thanks very much for joining us today, and we look forward to coming back and finding out a bit more of how it's progressed in the next years. Thanks for joining us today on this episode of the Cliff Notes podcast. If you'd like to get in contact with myself or the guest, the details are always available on the website, cliffnotespodcast.com, or we're on Twitter and Facebook on @CliffNotesPod, and we welcome all feedback and communication. Thanks again.